All right, guys, so this is the notes for section 5-6, and we're going to talk about inverse functions today, okay? So when it says just to find the inverse, it's simple, okay? So let's think of this. Remember f of x? We could also write this as y equals 3x minus 1. Okay, so to find and to solve for the inverse function, all we do is we switch the x and the y. Okay, so we're going to make this x equals 3y minus 1, okay? And then we're going to put it, we're going to solve this in terms of y. So we're going to add 1 to both sides. So x plus 1 equals 3y. So to get y by itself, divide both sides by 3. So you can write this one of two ways. You can just do x plus 1 over 3 equals y. Or you can do 1/3 x plus 1/3 equals y. Guys, these are the same. And you could write it either way. I would prefer this way because we're going to start graphing these, and this is y equals mx plus b. But either one of these two equations would work right here. Okay, so knowing what you know now, I want you to go ahead, pause this, try to do b on your own, and then we will review it. All right, so hopefully you've done this by yourself. So this is y equals 2x plus 8. Okay, so to find the inverse, we're going to flip our x and our y. So x equals 2y plus 8. And then we're going to solve this for y. So minus 8 on both sides. So you get x minus 8 equals 2y. Divide both sides by 2. You get x minus 8 over 2 equals y. Or I prefer to write this as y equals 1/2 x minus, guys, 8 over 2 is just 4. So both of these are the same thing, just written very differently, and I would accept either one of these. All right, so let's look at example 2a, okay? So we want to find the inverse of f of x equals x squared. And we're restricting our domain, and we'll go over here in a minute why we had to do that. Okay, so if I graph x squared, right, you want 2, 4, 1, 1, 3, 9, it would look something like this. Guys, it's really hard to do on this tablet, but I'm trying. So this would be y equals x squared, okay? But we're restricting our domain to where x is greater than or equal to 0, and we'll go over why here in a minute. So I'm going to actually just delete this entire graph to show that, or not the entire left part of it. Okay, so now I've restricted my domain. So just like I did before to find the inverse, so f of x equals x squared can be written as y equals x squared. So I want to flip my x and y, and then solve for y, so I'm just left with the square root of x equals y. Okay, now go back to us restricting it. I have y is greater than or equal to 0 because if it's less than 0, this doesn't exist. Okay, that's why we had to restrict it. So if I graph that, it would be something like this. Okay, and one thing I want to show you is that when we do inverses, this is the line y equals x. Okay, and inverses, when you graph them, it'll always be a reflection over the line y equals x, assuming you did it correctly. So if you graph it and it's not, you should probably double check yourself. Okay, guys, remember inverses is you do and then you undo, and that's kind of the point of it. And that'll bring us really into next chapter when we do logarithms. All right, so using the example we did in 2a, I want you to try 2b by yourself. And notice, once again, we're restricting our domain, but this time it's x is less than or equal to 0. Okay, so go ahead and draw your graphs based on that right there. All right, so hopefully you've done this. So we want to restrict it to less than or equal to 0. So the line y equals negative, y equals negative x squared is right here in red. Okay? And then when we find the inverse, we get the square root of negative x equals y, which is why we had to restrict this. Only a negative number can come in here because a square root can't be negative. So this is valid. And so this would be our inverse right here. And when we graph it, we would get the green line right here. And once again, this is a reflection over the line y equals x. And so that should just kind of confirm that that's our correct answer. All right, guys, so now we're going to talk about the horizontal line test for a minute. Okay, so the vertical line test was used to see if something's a function. And the horizontal line test is used to see if the inverse is a function. Okay, so basically what this tells you is if you can draw any horizontal line through a function, so like here we drew it through right here, okay, it only intersected at one place. Therefore, the inverse will be a function, okay? Now, if we have a function like this, okay, and we draw this horizontal line or any horizontal line, it can be anywhere, guys, it will intersect this graph at two places, okay? Because it intersects it at a place more than once, this inverse will not be a function, okay? And if you can draw it in one place and it hits it once, but another place it hits it twice, that is not a function, okay? Any horizontal line at all you can draw where it hits it twice, the inverse will not be a function. So with that in mind, let's look at example 3. All right, so we want to consider the function f of x equals 3x minus 2. Okay, so if I graph this right here, and we are right here, and it looks something like this. Okay, so this is our function. This is f of x equals 3x cubed minus 2. Okay, now I can draw any horizontal line here. Okay, I can draw an infinite number, and that horizontal line will never intersect that graph at more than one point. And therefore, by doing the horizontal line test, I know that the inverse of this is not a function. Okay, now we want to find the inverse. Okay, so once again, this is y equals 3x cubed minus 2. So what I'm going to do is I'm going to interchange the x and y. So x equals 3y cubed minus 2. If I add 2 to both sides, I'm left with x plus 2 equals 3y cubed. Okay, divide both sides by 3. I get x 1/3 x plus 2/3 is equal to y cubed. And then in order to get rid of the y cubed, you have to cube root it. Okay, so our y would be cubed root of 1/3 x plus 2/3, and that would be our inverse right there. All right, let's look at example 4 here. Okay, so we have f of x, or I'm just going to say y equals 3 square root of x plus 4. Okay, if we graph that, we start here, and then we go to somewhere like here. Okay, so this is y equals 3 square root of x plus 4. Okay, now let's go ahead and look. Now there's no horizontal line I can draw that'll intersect this more than once. This looks like it flattens out, but it slowly keeps going up as well. Okay, so it still won't intersect it twice. So the inverse is a function, okay, by the horizontal line test. So if I find that inverse, I would flip my x and y plus 4. So divide both sides by 3. I get 1/3 x equals square root of y plus 4. Okay, to get rid of a square root, I square both sides. Okay, so I'm left with 1/9 x squared equals y plus 4. Okay, and then subtract 4 from both sides. Okay, here is my inverse. Okay, so when I draw this, notice this is my range here is all positive numbers, so my domain here is going to be all positive numbers. So I'm really going to start here. Okay, so x is greater than or equal to 0. Okay, and when I do that, I hit here, and then I hit here, and I do something like this, and they end up crossing. Okay, so here's what you would end up with. All right, let's look at composite functions. Okay, so we would say this with the little thing here is f of g. Okay, this here is f of g of x, kind of like we'd say f of x, it's just f of g of x. And so therefore, because these are the same, this would be f of g of x. Okay, I know the notation can look pretty tricky, but it's really not that hard. Okay, so when we do these, it's going to give you an f of x and a g of x. Okay, so just like if we had, I don't know, f of 1, okay, we would just plug in 1 for every x in function f. Okay, so we're going to do the same thing here. Okay, so f of g of x. So we're going to start with function f, but for every x, we're going to put in the whole function g of x. Okay, so f of x is 2. Now x we're going to replace with g of x, which is square root of x minus 3. Okay, so this would just be f of g of x. Okay, over here, if we want to find g of f of x, now we're going to take the function g and we're going to plug in the whole function f of x everywhere we see an x. So the function g is the square root of x, right? But we're going to plug in f of x where x was, so we're going to put in this whole thing, 2x minus 3 here. Here's my g of f of x. All right, guys, let's look at example 6. Okay, so if it says verify their inverses, what we want to show is that f of g of x is equal to x, and we want to show that g of f of x is equal to x. If this is satisfied, then they're inverse functions. Okay, so what I want you to do is try to get f of g of x, and don't assume they both equal x, and trying to get g of f of x, and then we'll look at them. So I want you to pause this, try to do these, look at what we did in example 5, try to do these, and then we'll go over it. All right, when you found f of g of x, you start with f of x, but everywhere you see an x, you're going to put the entire g of x function in it. Okay, so when you do that, you get here, the 2's cancel each other out, so you're left with x minus 4 plus 4, which is just x. Okay, now g of f of x, we're going to take the entire function of g. Okay, so this entire thing, but everywhere we see an x, we're going to put f of x in it, which is the whole thing. Okay, so when I do that, I get 2x plus 4 minus 4 over 2. Well, the plus 4 minus 4 go away. I'm left with just 2x over 2. Well, then the 2's cancel out, and I'm left with x. Okay, because f of g of x is equal to x, and g of f of x is equal to x, that means that these are inverses, and that's all we have to do.